Okay, welcome to 321 exams. Today I'm going to be a physics teacher and we shall be considering the topic gas laws. Now, under this subject matter, we'll be taking a look at the behavior of gases under some set of conditions like the increase in temperature, pressure, and perhaps what happens to the volume and so on. Now, the first subtopic under the gas law I would like us to consider today is the Boyle's law. Some time ago, a physicist called Robert Boyle took time to study the behavior of gases and he came up with a conclusion. And that conclusion, after further verification, resulted to the formation of a law, and that law is called the Boyle's law. Now, the question is, what does it state? Now, the Boyle's law made us to understand that the volume of a given mass of a gas is inversely proportional to the pressure. That is, the volume of a given mass of a gas is inversely proportional to the pressure provided that the temperature remains constant. We have all been introduced to the topic variation in our elementary mathematics. That is, when you were in your junior classes, you went through variation. Now, the essence of me taking you back to variation is this term, proportional. There is a proportionality there. Therefore, mathematically, we are made to understand from Boyle's law that the volume of a fixed mass of a gas is inversely proportional to the pressure. Remember, another way you can state this is that the volume of a given mass of a gas is directly proportional to the reciprocal of the pressure. And there is a constant on proportionality there, which is the temperature, right? So mathematically, we have V is proportional to 1 over P. If we want to remove this proportionality, we introduce a constant so that V equals to K multiplied by 1 over P, where K is a constant. And therefore, if we cross-multiply, the constants will be V what? PV. And from this, we can conclude that P1 V1 equals to P2 V2. Now, what Boyle's law is trying to say is that the volume is inversely proportional to the pressure. That is, when the volume is increased, the pressure reduces and vice versa. The diagrammatic representation of Boyle's law is stated below. You can draw the graph like this. This is the volume and this is the pressure. Now, because it's inverse, you have something like this, or you can have it this way, the volume to the inverse of the pressure, then you have it like this. And if you want to represent Boyle's law, you can represent Boyle's law this way using this diagram. That's we have the volume 1, the volume 2, and we have the pressure 1 and the pressure 2. So from this diagram, you can see that as the volume is increasing, the pressure is decreasing by the same amount and vice versa. And that is why it states that the volume of a given mass of a gas is inversely proportional to the pressure. Now, one thing I want you to understand as far as this branch of physics is concerned is this formula for Boyle's law, that is P1 V1 equals to P2 V2. Then the next thing we need to go over is the Charles law. Just like Boyle's or Robert Boyle, another physicist called Charles stated the law, that is Charles law. Now the question is that what does it state? Now, Charles' law made us to understand that the volume of a given mass of a gas is directly proportional to the temperature in Kelvin, and that is the absolute temperature, provided that the pressure remains constant. So Charles' law made us to understand that the volume of a fixed mass of a gas or a given mass of a gas is directly proportional to the temperature in Kelvin, is directly proportional to the temperature in Kelvin provided the pressure remains constant. Mathematically, the volume is directly proportional to the temperature in Kelvin. That means as the temperature increases, the volume increases and vice versa. So removing this proportionality, we introduce a constant, V equals to KT, so that K will give you what? V over T. Therefore, for Charles' law, we now have V1 over T1 equals to V2 over T2. Do not forget that the temperature is the absolute temperature. And how do you get your temperature in Kelvin? We are made to understand that the temperature in degrees Celsius plus 273.13 will give you your temperature in Kelvin. This is called the absolute temperature. And that is why the law states that the volume is directly proportional to the temperature in Kelvin, or the absolute temperature, provided that the pressure remains constant. So one thing you need to understand about Charles' law is V1 over T1 equals to V2 over T2. And remember, your temperature must be in Kelvin. Now let's look at the graphical representation of Charles' law. This is the volume and this is the temperature in Kelvin. Then this is 273. So this is the graphical representation of Charles' law, that is volume against the temperature in Kelvin. And if you want to do a diagrammatic representation of Charles' law, you have something of this nature. Then we have this. So we have V1, V2, V3. Let's assume we have 3 volumes. Then we have T1, T2, T3. You can now see that even as the volume is increasing, so also the temperature in Kelvin. So that is the diagrammatic representation of Charles' law. Then we go to the next law, which is the pressure law. This pressure law, some people call it the Geluzas law, right? And the pressure law made us to understand that the pressure is directly proportional to the temperature. Pressure of a given mass of a gas is directly proportional to the temperature in Kelvin, provided the volume remains constant. Right? Now, mathematical representation is this. Pressure is proportional to the temperature in Kelvin, and pressure equals to KT, so that K will give you pressure over temperature. And from this, P1 over T1 will be equals to P2 over T2, So this is the representation of the pressure law. I told you some people call this pressure law the Geluzas law. But the Geluzas law is also a law in chemistry. So please, I won't want you to confuse this. And that is why I've been a bit quiet on the Geluzas law. Now we'll go to the standard temperature and pressure. Now there is something called the STP. And that STP is standard temperature and pressure. So the standard temperature for all gases is 273 Kelvin, and the standard pressure will give you 760 millimeter mercury, because mercury is used in the barometer that is used for measuring the pressure, right? Or 101,325 Newton per meter square. So you either have 760 millimeter mercury, 76 centimeter mercury, or 101,325 Newton per meter square. And this 101,325 Newton per meter square can also be expressed in standard form as 1.013 times 10 raised to the power of 5 Newton per meter square. So these are the standard temperature and pressure. Standard temperature is 273 Kelvin, and that is why for every degree Celsius you are given under this aspect of physics, you have to convert to Kelvin by addition of 273. Now, under this topic too, we have to consider what is called the general gas law. Now, the general gas law tends to combine Boyle's law, Charles' law, and also the pressure law. And for that reason, we have the general gas law as P1 V1 over T1, which is equals to P2 V2 over what? T2. So this is the general gas law, and we shall be making use of this general gas law to solving problems as we proceed. And finally, we are going to what is called the ideal gas equation. The ideal gas equation has a general formula too. And remember also the fact that the ideal gas depends also on these parameters that we've been talking about before now. And therefore, the ideal gas equation is given as PV equals to nRT, where your P is the pressure, V is the volume, N is the number of moles, that's the mass over the molar mass, R is the molar gas constant. It has a constant value that it shall be given, that's 8.31, and T is the temperature in Kelvin. With this, I believe we have come to the theoretical aspect of gas laws. Now let's go over to JAMB questions and see how we can apply these laws to solving problems. Now the first question I want to consider here is obtained from UTME 2019. This question also came out in JAMB 1999. Now we are given the equation PA VB TC equals to constant reduces to Charles' law if, remember, or you can recall that under Charles' law, the volume is directly proportional to the temperature, and therefore the constants will give you V over T, which is still the same thing as V1 T raised to the power of what? Minus 1. But there is no P here. And for that reason, we can add our invisible P, which is P to the power of 0, V1 T raised to the power of minus 1, considering the fact that any number to the power of 0 is 1, except the number is 0. So P raised to the power of 0 is 1. And at the end of the day, it still comes out to this principle. And for this reason, P0, V1, T1 will now be equals to VB and TC. Comparing both, you have A to be equals to 0, B to be equals to 1, and C to be equals to minus 1. Remember this, minus 1, not 1. So this gives you the solution to the question under Charles' law. Now let's go to the second example. Example 2. The pressure of a gas at constant volume is 110 centimeter mercury at 37 degrees Celsius. Calculate the pressure at 77 degrees Celsius. Now, if you take a look at this very well, we are talking about the relationship between pressure and volume, right? And this, and also temperature, as the case might be. The pressure of a gas at constant volume, that's the volume is constant, is 10 centimeter mercury at 37 degrees Celsius. Calculate the pressure at 77 degrees Celsius. That is, we are talking about pressure and temperature. right? Because the volume is constant.